Hello, it's Miss Flannery, and we are going to talk about solving systems, linear equations, and we've talked about how to do that a few different times in a few different ways. And the three different ways that we've talked about are by graphing. We can solve a system by graphing it and seeing where the two lines cross. Substitution, where we could not be a bad substitute, we could be a good substitute, and we could take out, you have to solve for a letter, and then you take out a part of it and plug it in the other letter, the other equation, all sorts of craziness. And it's awesome and tedious, but effective. But we've also learned a third method called elimination. It's also known as the multiply and add method, because that's what you do. This is the one we're going to talk about today because we really need to get good at that method. We have got to rock the process, not just checking out the graph and seeing where they cross on Desmos, but actually getting really good at this elimination process. And every time, the way this process is going to work, you're going to look for something called additive inverses. Additive inverses. Ka-chow. An additive inverses is a fancy way to say two things that add together and equal 0. For example, 3 and, yes, that's right, -3. They add to 0. What about negative 5x and, yes, that's right, 5x. You're so smart. So there's lots of different pairs, and what you want to do is you want to look in your system. You're going to try and find a pair of additive inverses on either the x's or the y's. That way, they can add to 0, and we can then eliminate them, which is very nice. So that's our goal. So our goal on this, looking at this example over here, we're going to call this example A, the easy one. And on this example A, which one looks easier to get rid of, or do you see any additive inverses? Heck yes, you do. Look at that right there. 2x and -2x. Ka-chow. It's already there. Feels like we're cheating already. So all we have to do then is just add straight down. And that's exactly what we're going to do. We're going to add both equations. I'm going to put a plus sign over here. I'm literally going to add straight down the like terms, the terms that are like. So -2x plus 2x plus -2x adds to 0, aka that variable is now eliminated. And then 3y plus 1y is how many y's? That's right, it's 4. 4 y's. And then 20 plus 4 is 24. Okay, so now we've got this simple little equation, and all we have to do is solve for the variable. And in this case, what is bothering that y? Well, the 4, it's being multiplied. So to get rid of it, we do the opposite, or the inverse operation. So we're going to divide. Turns out y equals 6 in this case. Dun, 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 dun. Lois Emos, we did it. Okay, so now we got y equals 6. But I'm telling you, we are not done yet. Why? Because when we started this equation, this example, we had both an x and a y that were missing. Well, we only found one of them. We found the y. Now we got to find the x. So we are going to take that handy dandy y we just found, and we are going to plug it into one of the original equations. Now I'm what I like to call efficient. Others might call it lazy, but you know, details schmetails. So I like to pick the equation, either one of these two, that just looks easier for me to deal with. And I like smaller numbers. So I'm going to go with this equation number 2 that I have handily named equation 2. So equation 2, I'm going to take out the y, and I'm going to put in there what I know y has to be. And we said that y is supposed to be 6 for this thing to work. Hence, I'm going to put in here a 6 instead of that y. Okay, well, now I got to solve for x, and this is just, a simple linear equation with one variable. So we'll start with the thing that's farthest away on the same side of that letter, and that would be this plus 6. So to get rid of it, I'm going to subtract 6. Oops, my bad. Let me undo that for a second. There we go. So I'm going to subtract 6 to get rid of that 6, because now that adds 0. Now I have negative 2x equals negative 2. Now, to get rid of this negative 2 in front of the x, I divide both sides by negative 2 again. And negative 2 divided by negative 2 turns out is 1. Okay, so now I solved for both. I had two equations with two letters, and I solved both of them. So my answer is either 1, 6 or 6, 1. And you have to decide. Or you have to look at, not decide, you have to look at which one has the x, that one goes first. So that would be wrong. Okay, you want this one over here that says 1, 6. That is the coordinate pair that is the solution to this system. Ba ba ba!